All right, welcome to Foundations of 30. This is FM30.07. We're looking still at polynomial functions. This is part 3, cubic functions. So this is new. Cubic functions are new for Foundations 30, and the parent function is y is equal to x cubed. As indicated by the name, these have a degree of 3. Okay, so y is equal to x cubed is the parent function. It's shown on the right here where we have this nice little swooshy line here like this, passing through the point 0, 0. It's similar to the line y equals x, which is straight, but this one has a curve in it. And the new kind of word we're going to talk about here is the leading term. So the leading term of any polynomial is the term containing the highest power of x. So when I look at this function right here, 2x cubed plus 2x squared minus 4x, my leading term is 2x cubed. Okay, so we're going to use the graphing calculator to explore these. We'll do the first one together. So when I enter in y is equal to 2x cubed plus 2x squared minus 4x, I get a picture of a cubic, and my leading term here is 2x cubed. We already talked about that. Okay, so what we want to do is we want to try to put this graph on the calculator or onto the graph paper. So we know that the point 0, 0, we're going to use that trace function and grab some values here. So when I say when x is minus 1, y is 4, is up there. When x is minus 2, y is 0. When x is 1, y is 0. When x is 2, y is 16. So it's way and gone up there. So basically what we have is a picture, looks like that's my high point. This comes down here and it goes back up again like that. Okay, so my end behavior, we know that this is quadrant 1, 2, 3, and 4. So when I read this left to right, this goes from quadrant 3 to quadrant 1. The domain of this, well, this would be x would be an element of all real numbers because this goes forever in both directions in the x. Same in the y, those arrows indicate it's going to go up and down forever. Now the number of x-intercepts, so I don't care really what they are. You can trace function trying to figure out exactly where they're at, but how many are there? So there are 1, 2, 3 x-intercepts, and there is 1 y-intercept. Okay, so the other question that you're being asked here is how many turning points are there? So remember that turning points are where the graph changes from increasing to decreasing. So I'm increasing, now I'm decreasing, now I'm increasing again. So I have a turning point here and then another turning point down here. Think of them as like the vertexes of a parabola. Okay, so I've got 2 turning points on that cubic. Okay, so you're going to go ahead and graph the other 2 and then talk about end behavior, and then we will have a quick summary.